1. So, good morning, good afternoon, or good evening, teacher. Today, we are going to explain the topic of cylindrical and spherical coordinates. Our team is made up of Adriana Cortés Cruz, Vanessa del Ángel Nieves, and Alejandra Sánchez Gonzaga. We start by explaining a little about cylindrical coordinates. So, cylindrical coordinates constitute a generalization of the polar coordinates of the plane by extending them into space parallel to a straight line. That straight line is the z-axis and is perpendicular to the x and y plane. And we have a small image for to represent and understand the cylindrical coordinate a little bit more better. So we also have some equations that we will use to be able to solve the examples that we have below. The first equation is for to convert from cylindrical to rectangular coordinates. And we have x is equal to r cosine theta, y equal to r sine theta, and z equal to c. And the second equation that we have is for to convert a rectangular coordinate to cylindrical coordinate. And we have r squared equal to x squared plus y squared. The next is tangent of theta equal to y divided by x, and c equal to c. So now, knowing all this information and equations, we will begin with the explanation of some exercise. So we have the first example.
Hi, teacher. We had as an example Cartesian 2 cylindrical. We had a negative 2 rod of 3 commas 2 commas 3. We have 2 r is equal to a square root of negative 2 root of 3 squared plus 2 squared is equal root of 4 multiplied by 3 plus 2 is equal to 4. Theta is equal negative negative is equal to the inverse tangent of y over x. Theta is equal to 33 is equal to 115. Next.
And we have our second example. And this example tells us we must to convert from a cylindrical coordinate to a rectangular coordinate. And in pink, I write the shape of our example has, and now it should be. So we are coordinates say a square root of 2, comma, 3/4 of p, comma 2. So we need to use these equations for to resolve. And the only thing that we need to do is put the numbers in the correct order. So I will start. I write in pink R, doing a reference to a square root of 2, and theta is the same of 3/4 of p, and c is equal to 2. So knowing all that things, we can resolve our cylindrical and rectangular coordinates. So we need to put the first equation, and we have x equal to a square root of 2 cosine of theta, but theta is 3/4 of p. The only thing that we need to do is multiply 3/4 multiplied by 118, and the result of this multiplication is 135. So we need to put all this equation in the calculator, and the result that we have is x is equal to -1. This is our first result. The next thing that we need to do is put the same things that I was explaining in a moment, and the result that we have is 1. And one of these equations says C is equal to C. And I write in pink, C is 2. So the only thing that we need to do is put this expression. So the result is, in parentheses, we need to put -1, comma, 1, comma, 2. And we have the rectangular coordinate of that cylindrical coordinate. And this is the second example. The third example, sorry.
Okay. Hi, teacher. I'm Adri. And continuing with the exercise, here we have exercise of cylindrical. Um, we our exercise is -2, comma 4 divided by 3 3p, comma 2. Um, uh, these are the formulas, and we are going to occupy all the numbers of the exercise here in x is equal to minus 2 cosine 240 x is, and we are going to put in the calculator the result is x is equal to 1 and next, and y is equal to minus 2 same 240 and y is equal to square of 3 and c is equal to 2 and as a result we have 1 comma square of 3 comma 2 and continue with the exercise.
We have an example, cartesian to cylindrical, equals r is the square root of in brackets 2 squared plus in brackets minus 3 squared r is equal root of 32 and theta is equal inverse tangent in brackets negative 3 over 2. Theta is equal negative 55. Theta is equal 120. Z is equal negative 4. Next.
Now we have spherical coordinates. That spherical coordinate we use an ordered triple to describe the location of a point in space. In this case, the triple describes a distance and two angles. The spherical coordinates make it easy to describe a sphere. And we have again an image for to understand and show the behavior of the spherical coordinates. And we have the equations for to resolve the below examples that we have. For to convert an spherical coordinate to a rectangular coordinate, we use these equations. The first equation says x equal to rho cosine of theta and sine of p. The next is y equal to rho sine of theta, sine of phi. And the last one is c equal to rho cosine of phi. And the second equation that we can use is for to convert rectangular coordinates to cylindrical coordinates. And we have rho squared is equal to x squared plus y squared and c squared. The next is tangent of theta is equal to y divided by x. And the last one is phi is to inverse cosine divided by c divided by square root of x squared plus y squared and c squared. And we
have as an example spherical to cartoon. In brackets, we have two commands, 2 trees, p, commands for p. Find x, y, z. X is equal to cosine of 120 sine of 45 is equal to negative to the root of 2 over 2. Y is equal to brackets. Oh, sorry. To sine of 120 sine of 45 is equal of negative root over of negative root 6 over 2. C is equal to cosine of 45 is equal to root of 2. Next.
And we have the second example, and we need to convert a spherical coordinate to a rectangular coordinate. And the coordinates that we have are 4, 5/4 of p and p divided by 3. And we need to use these equations for to resolve. And the only thing that we need to do is put in order the numbers in rho is 4. Theta is 5 quarters of P. And phi is P divided by 3. If you remember, the only thing that you need to do to have the grades that we have here, you need to multiply 5 quarters multiplied by 180, and the result that multiplication is 225. And for to convert P divided by 3, you need to divide 180 divided by 3, and the result is 60. And knowing that, the only thing that we need to do is put in order the numbers. So we start. X is equal 4 cosine 225 multiplied by sine of 60. And the result is negative square root of 6. And the next equation is 4 sine of 225 multiplied by sine of 16. And the result is y is equal to negative 6. And the last one is c equal to 4 cosine of 60. And the result is 2. And we need to put in order the numbers. So the result is the next. Minus square root of 6, comma, negative square root of 6, comma, 2. And the next example is
as the last example we have is a coordinate rectangular. At the top left is for exercise. That is 3,3 divided by 2p, p divided by 4. And we have the formula to get those. First we start with x. Its formula is x equal to rho sine in parentheses c cosine in parentheses here um, uh, uh, after x is equal to 3 sine in parentheses p divided by 4 cosine in parentheses 2 p divided by 3. The result x is equal to minus 1.06. In y, its formula is y is equal to rho sine in parentheses c sine in parentheses here y is equal to 3 sine in parentheses p divided by 4 sine in parentheses 2p divided by 3. And with the 3, no, sorry. We are going to put this in the calculator. In the result is y is equal to 1.84. Next, EMC is equal to 3 cosine in parentheses e divided by 4. We are going to put this in the calculator. In the result is C is equal to 2.12. And with the 3 results, we form the cylindrical coordinate is minus 1.06, 1.84, 2.12.
And thank you for the attention. That is all. And see you in the next video. Bye.
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 Hi, teacher. I'm Vane.
Hi, teacher. I'm Adri.
Hi, teacher. I'm Ale.